So my name is Ned Letcher. I'm from Forefront Analytics. We're a consultancy. We I help organizations find insights in their data around business intelligence and analytics. Also sort of stuff in data science side of things. So what you might expect, machine learning and text analytics and the like. And I'm also very close, increasingly closer to finishing submitting my thesis at uni Melbourne in computational linguistics. So I wanted to ask you all a question to begin with. Who here, put your hands up if you've been in a situation where you've done some analysis, you want to communicate your results of this analysis using a visualization, but you're struggling to because of resource constraints, time, money, skills, or anything like that. Can anyone relate to this? Yes, so I think like almost everyone, I think. If you've tried to do visualization, that's a common. It certainly happens to us in our organization. Hey, wonderful. Oh, it's that one. Oh, okay. Yep. Cool. All right. So imagine that you're in some small team. It's possibly so small it's just yourself. You've got some data. You've done some analysis. You want to communicate these results with the visualization. It needs to be interactive. Maybe there's some parameter you want to sort of like. Could be a model predictive analytics for forecasting, and the parameter might be what month is this applying to, or something like that. It also needs to be shareable. You need to be able to share it with your team or the world. But as I just said, we have time constraints. You might not have many people in your team, and also skills. We don't necessarily have all the skills we need to sort of make this happen. So what are ways we could go and do this? Well, we could use a JavaScript library we've sort of seen already, D3, very popular, Plotly.js, Chart.js. These are all great options, and if you're building a sort of a very custom domain-specific application, it's a good chance you'll have to go for one of these. But if you're in the business of doing just sort of data wrangling and just coming up with analysis, you need to communicate it, you probably don't have time to just go and build out a JavaScript app. Most data scientists or analysts aren't sort of front-end developers, or certainly not full-stack developers. So what do data scientists and data wranglers, practitioners use? Well, R is one thing that a lot of people use. So if you're using R, you probably want to use Shiny, because that does this for it. You can build reactive web applications straight from the model that you've already built in R. So I'd recommend that. But what about Python? That's another very big popular library, in which case you might already be using Jupyter to do your analysis. The problem with that is even though you can share notebooks, you can't make the notebook shareable to the world, because then you're exposed to the kernel, and then therefore access to your machine. You can use Jupyter Dashboard Server to sort of help with that, but it doesn't scale. You get one kernel for each request, and then that's, if you've got a sort of a 1 gigabyte file that you've loaded up as a CSV, that's 1 gigabyte per person. You can't have many people serving that. Bokeh server, this is actually going to meet these needs. I haven't used it myself, so it looks like it's going to tick a lot of these boxes, but I do feel like it might be a little bit complex in the interface. So it could be a good option worth exploring. But I want to talk to you about Dash, which is, as we've been hearing about, a new library put out by Plotly. And what it does is it allows you to build Python frameworks for building analytical web applications. You get to create modern reactive web apps just using Python. And this is sort of the real sort of winning thing here. It's built on Flask, a Python web framework, very popular, and also on the front-end side, React, a JavaScript library. But you don't have to know React, which is the wonderful thing. OK, so we have here a reactive visualization. What it is a bunch of indicators about sort of population levels. So let's have a look at. I'm going to open up CO2 emissions. Now let's compare that with, I think, something that's probably going to be interesting is electric power consumption. There seems to be a trend. Let's turn that into a log scale. And yes, look, unsurprisingly, there's a trend. Now, this was meant to be full screen, so you wouldn't see. So the big reveal has already been revealed. These slides that I'm showing you are, in fact, a Dash application, which is why we can have it built into the presentation itself. And what what do we mean by a reactive visualization? I mean, we could just replace that word with interactive, but specifically, reactive is a little bit more nuanced. And what it means is, yeah, so we don't quite fit on the screen here. But what it means is that when a user makes a selection, that is sent off to the server with different inputs as these selections. It calculates updates the data, and it sends it back out. And inserts it into this web app. And only that bit of that data has changed. So that's the reactive bit. And it sort of makes things a bit more efficient. So let's unpack this, what's going on under the hood. So this is what you're writing here, the Dash app, which consists of HTML layout and function callbacks. I'll get into them in a second. They're basically, it's all in Python, and that's what you have to concern yourself with. This communicates with the Flask server, all of which can either be run on your own machine or in the cloud. So this can be a remote web app, which in fact mine is. Mine's running on my machine at uni. It's probably, you can visit that and it should work. And it probably won't even crash this. Maybe don't. The Flask server is communicating with the React app that we're looking at right now. And when I click on the drop-down, it sends a JSON request to the Flask server, executes the function callback, which reproduces the new data. And it's sort of magic, because, yeah, everything's written in Python here. So a very quick Hello World app in Dash simply looks like this. We create some data, we define a new app, then we define the layout. So if you look at it, you'll see that there's a div with a heading and a graph element. The graph element is this thing here. And we're putting into the graph element that data there. So that's simply just a sample from a normal distribution. And we get it back. And so that was it. Pretty neat. But it's not reactive. That's just a sort of a static. And yes, and so I guess implicit in that is what you've concerned is the first part of the Dash app is the layouts. So layouts are reusable component trees. Here are some component trees. That's the one we just saw before, a div with a h2, a heading, graph p. We could also have a div with some unordered lists, or even had some Markdown. I'll get back to that later, and some images. What that means is we're writing our HTML components in Python, and these become reusable libraries. You can actually compose these, so we could embed one of these within another one, and then share these layouts amongst our team. These layouts are converted into JSON, and then that's sent back to your app, and you get a new funky interface with the changes that you've requested. So now how would we make this reactive? What we do is, once again, we create a new app. And I guess my point in showing the code is not necessarily going to be clear, more that this is a complete app. Just that's sort of the main thing that I'm giving you a sense of and how it works. It is as simple as this. We create our graph, and here we have the slider input. That's what's different here. And then we've also defined the callback, and that's just saying attaching the slider to the graph, basically, injecting here's our slider down below. Now, when we trigger the slider, what you'll see, and I've actually attached the slider to so you'll see that it's changing the standard deviation of the normal distribution, the sample that it's, and obviously you can see that reflected as we scroll along. So that's as simple as that. All of that code will generate what you see there. And this is a Plotly visualization, so you've got total, everything that Plotly gives you out of the box, you've got that there. So the second thing that I've already alluded to is essentially the callbacks. This is where you make your data that when you've sent a request, you've said, hey, I've updated the standard deviation from the slider. The callback is just this. It's just a Python function where you attach the input is the slider, and I'm saying, hey, I want the graph element with the ID graph, and I want to change its figure. You can't see that, but implicitly the graph has a figure, and all we're saying is then down here, this function returns us a new figure. That's this dictionary, new figure with the histogram. And so then that's it. That's the magic that happens. There is a intro guide that the Plotly people have put out. So all of this is in that, and that's what I recommend going through. Just sort of quick whirlwind tour of how this stuff works. So basically, your Dash apps are layouts and callbacks. And your callbacks refer to IDs in the layout. And that's all your Dash apps are, essentially. Some other neat things that we get. How I made all of these slides is using the Markdown element. So I can just say, hey, my app is simply the Markdown element, and here Markdown is just a very simple markup language, and it generates this HTML on the side there, which made writing these slides actually a whole lot easier, so pretty convenient. We can also make single-page apps, which is what you're looking at, these presentations. Details aren't necessarily too important, but it's just interesting to note that we can build it with one simple Python function that's just checking the incoming string, the route. Is it the root route? Is it viz1 or is it viz2? Or if we didn't find it, then we'll return the page not found layout. And then it builds up the whole layout that you've asked for and replaces the whole kit and caboodle. So it's actually kind of, you're looking at the one page where this big giant element has been replaced. And that's essentially the single page app that we're getting here. So this is running on my machine on campus at Melbourne Uni. It's not too hard to get this running online. It comes with a development server from the Flask app. You can use this for development. I wouldn't recommend using this in production because it will block on each request. So when a user makes a request, it won't do another request until it's completed that one. But if you use a WSGI server, of which there are plenty, Unicorn, uWSGI, or Apache with ModWSGI. And any of these are really, well, some of them like you can get running with a simple command line. If you would just Google something like hosting Flask apps on blah, where blah is the platform you're interested in, you'll find instructions on how to do it. Or ask, hopefully, if you have one, your tech team, tech support. So there are some limitations, obviously. Out of the box, it only supports Plotly visualizations, but you can create your own React components if you are that way inclined, which is going to be a little more complicated. But if you have someone on your team who can do that, then obviously this opens up a whole lot more power to you. It also means that you're creating a different artifact than, say, the Jupyter Notebook. That's one potential. You do have to create another thing, but as you saw, it's a pretty lightweight thing. You can plug into existing functions that you have. And also for layout changes and any requests, you have to do a server request. So it just, everything will take a little bit longer compared to a regular React app where it's all done locally, unless it does need to get new data. But if you're making changes to the layout, like just changing the page, you could even create your own internal component, and then that won't require a server request. I'm really excited about this. I think it enables people with just Python skills, or you could pick up the Python skills required for this to build modern front-end web applications without knowing any JavaScript. The only JavaScript I used in this was to hook up the left and right buttons with the back and forward. Everything else came from the React. Teams can create reusable libraries of apps and layouts. So you've got, this presentation app can be a reusable one, or different analysis with layouts and chart plots that go in them can be shared. And I think it's really relevant for anyone. Analysts, researchers, communicators, enthusiasts, sort of anyone. I think the barrier to entry is really quite low. I would encourage you to check it out if it's the sort of thing that excites you. That's it.
Thank you very much. Yes, there are questions. Scala.
Thanks for that. That's good. I've used Dash before, and I quite like it. I've struggled with some of their documentation. Do you have any good? Because it's new.
Yeah.
Do you have any good sources of documentation that's a bit more kind of, it goes a bit further?
Yeah, I agree. There's no actual documentation. Documentation is the user guide. The user guide is great. Once you read it, you'll know how to do all that stuff. But it's not the doc. There's no docs. So that is one, and I found that a few times when I was making this. And unfortunately, that's where, yeah, I think it could use some improvement. There's a forum. Plotly have a forums, and there's a dashed thread in that, or channel. There's good discussions going on there. Other than that, I've just been digging around the source code. Yeah, sorry.
That's good.
Yeah, I was just wondering, at the start of your talk, you talked about Dash, where you wouldn't need to worry about learning JavaScript or anything else like that. But by actually starting to put it on the cloud, you're actually starting to think about sysadmin type duties.
Yep.
And as you say, like with Dash and with Shiny, they actually can allow you to get up to speed really, really quickly. Where does that grey area stop and start in terms of saying, well, we actually need to start taking this seriously and start moving away from that versus, keeping it, say, in-house, for example?
Right. So like where you would go from sort of using a sort of a more streamlined sort of solution to then rolling your own JavaScript sort of library set of tools.
Because I would say that sysadmin is like 100 times harder to do properly than learning JavaScript, for example.
Yeah, it depends. I mean, to do what I've done here, it's really actually not that hard. I mean, yeah, you need to go and read up, but like if you Google how to get Flask going on the cloud, you'll find instructions. If you've had any experience on a Linux command line, and obviously that is a barrier to entry, I recognize that, but but that's something that you can pick up. It's a few commands to get running. So I think it is accessible. I don't think it requires sysadmin skills, but it's still some kind of barrier. There will always be something like that. If you want to deploy an app that is going to be scalable and reach thousands of people around the world, obviously there's some amount of sysadmining involved. But here it's pretty minimal, I think.
Oh, thanks. That was super useful. I'm just wondering if your presentation is available in.
It isn't yet. I mean, because I will turn that off at some point. But my plan is to incorporate that into my, have that running on my home personal page.
I'd like to see the source code.
Oh yeah, it is. It's on my GitHub account. My GitHub user is Ned2, and you'll find it. But and I can share that, put it on the Twitters and things. Yeah. That's the digit 2.
Are there any more questions? If you would join me again.
Thank you.